So my dear children, now I have with me a Haberella plant leaf. As you can see here, this is the plant which is called as Haberella. So I have prepared a small bit of a plant as well, right? So this is the Haberella plant leaf. This is also referred as taro yam or else colocasia. So the specialty here is that when you take the leaf of Haberella, right? So I have a bigger leaf in here, right? So now what I'm going to do is I'm going to take some water from this dropper and I'm going to drop it like this. See? So if I'm going to put it like this, so if I'm going to drop it like this, observe how the water drops are getting collected onto the leaf. See? Now you can see the water drop in the middle of the leaf, right? And now what I'm going to do is I'm going to gently, see, I'm going to gently pour that water into the basket once more. Now when I'm touching it, right, as you can see, it's very clear to us. We won't be able to observe the wetness. Even though I'm pouring water onto the surface of the leaf, I can't feel any wetness. As you can see here, if I'm going to drop it like this, the water drops are getting poured down to the beaker once more, right? And you can clearly observe that the nature of the surface, nature of the leaf of the Haberella plant leaf is not trapping or not contacting with water. Even though it is getting contacted, right? So you can see that the water drops are getting repelled from the surface without any trouble. And we won't be able to feel any wetness on the surface too. It's because of the hydrophobic nature of the plant leaf. So this hydrophobic nature is the one which is referred as the lotus effect. So in here, my dear children, the surface of the leaf is having nanoparticles that can repel the water molecules. So if you put water into the surface like this, you won't be able to, right, see that water drops get in contact. I mean, like, it's getting contacted, but however, it's not getting retained with the plant leaf. See, there is no attraction between the water drop and the plant leaf surface. It's because of the hydrophobic nature. So if I'm going to pour it like this, without any trouble, I can pour that water drop once again to the water beaker and there is no wetness on the surface. So this is what do you mean by the lotus effect, my dear children. So not only colocasia leaf or else Haberella leaf, this effect can also be observed within the lotus plant leaf also. So that is why especially it is referred as the lotus effect. Okay, right. So I hope that you got the idea of the lotus effect, my dear children. So let's head on to the classroom once more and we'll study the further things related to the lesson. So my dear children, this is the structure of the fullerene ball, right? So this is like a football, as you can see. There are several faces in it. So here, the structure is prepared according to the structure given in your reference book. So here, as you can see, A is connected to the A part, C is connected with the C part, B is connected with the B part over here. And my dear children, in the same way, the letters are aligned to create the fullerene ball. See? So all of these point heads, these vertices, within these vertices, we can observe carbon. Okay? So the application of nanotechnology is used in here. Okay? So my dear children, this is the structure of fullerene. So I hope that you would also create this structure at your home. Right, so it is very easy to create. It's like building up a solid according to a structure, right? Okay then, so now let's head on to the classroom once more and we'll observe the other things contained in the lesson.